Welcome everyone, and thank you for joining our webinar in Power Electronics in Semiconductors. My name is Toni Mattila. I'm the head of semiconductor industry at Business Finland, and I will be your host today. Power electronics is a critical enabler of energy efficient technologies. It plays a key role in everything from renewable energy systems and electric vehicles to industrial automation and data centers. As the demand for electrification and sustainability accelerates globally, innovations in power electronics become essential. For the Nordic region, where Norway, Sweden and Finland are all leaders in clean energy, advanced manufacturing and digital infrastructure, collaboration in this field presents a strategic opportunity. By leveraging our regional expertise and the strong commitment to green technologies, the Nordics can drive the next generation of power electronic solutions that are both sustainable and globally competitive. In our webinar today, we'll explore some of the most promising opportunities, but also look into some of the most pressing challenges in this domain. Whether it's semiconductor innovation, supply chain shifts, or system-level design, we are here to dig deep into what's shaping the future of power electronics in the Nordics. It is my pleasure to welcome and introduce the distinguished panel of experts in the Nordics. From Sweden, we have Jr-Tai, or Chen. He's the CEO and founder of SweGaN. Welcome, Ted.
Hello everyone. My pleasure to be here.
SweGaN is a pioneer in gallium nitride on silicon carbide materials for high-performance electronics. And from Norway, we have Betty Aasheim. She's a vice president of sales and marketing at Kymera International. Welcome, Betty.
Thank you very much. Nice to see you all.
Kymera is a key player in advanced materials for power systems. And from Finland, we have Petri Korhonen, Director of Innovations at Kempower. Welcome, Petri.
Thank you. I'm happy to see you all.
Kempower is a company that designs and manufactures scalable DC fast charging solutions for electronic vehicles. Thank you for you all taking the time to be here with us today. Before moving into the actual panel conversation, I would like to provide each of you 5 minutes to present yourself in more detail, but also to present your company and point out the few points that you wish regarding this topic. And let's go in the order of introduction. So, Ted, the floor is yours.
Okay, thank you. My name is Ted, and I originally from Taiwan. Moved to Sweden in 2009, studied a PhD in Linköping University. I was lucky enough to start a company with my professor before I graduated. So the company was founded in 2014, so it has been a long time. And along the way, I think we continue to develop the technology, which is gallium nitride material growth, specific on silicon carbide. And that is the introduction that I would like to go through quickly with you. So about our company, you can see this is our product. It's the epitaxial wafers. We started from actually small wafers from 3-inch. Now we have a scale to 4-inch and 6-inch. It's transparent. So we are a company develops and manufacture customized engineered gallium silicon carbide epi wafers for both RF and power electronics. So the company has been expanding. We actually will show you very soon our facility in Linköping. We have already a couple of products in RF sector that has been qualified, and there are multiple qualifications are ongoing. And we also has been developing our material for power, high voltage power switches. So currently we are scaling our capacity to more than 1,000 wafers per month. Yeah. So this is our facility in Linköping, and it's south of Sweden, very close to the airport of Linköping. And the plant capacity right here is up to 40,000 wafers per year. And we now have our employees, roughly 30 people working in the company. So you can see here our target applications. Defense radar is our foundation. So the company was founded with the aim to support the ecosystem in Sweden and also European supply chain. So we have been progressing this, I think, very well. SweGaN today is in very good position for the European supply chain. We also have other opportunities outside Europe. And telecom is also important. It's another reason company was founded to support the ecosystem in Sweden. We have Ericsson. We also have other European system manufacturer. So that's a great opportunity for a company like us to grow. And we also, this material can apply to satellite communication, and then ultimately we hope this material can be well used for power switches. So you can see the markets we are addressing for both RF and the power. They are already today, it's a multi-billion dollar opportunities. We are in a value chain. I will show you very soon. So the goal of a company is very aggressive. As you can see here, we would like to be a major player, especially in defense and aerospace. And also we want to be a sizable and reliable supplier for telecom. And hopefully we can also enter power in a few years' time. That's how we position ourselves. So if you look at our product and also its position in the supply chain, you can see we actually today we procure silicon carbide wafers and we use it as a substrate, and we grow this high performing gallium nitride transistor epi structures on top of that. And that's has been our expertise. And we have a very unique solution that enable very high performance. And then we sell these epi wafers to our customers, who are typically foundries, or we call it IDMs. Yeah, and this is the where we are in the supply chain. So a couple of years ago, the company has made a breakthrough in the field. This is our product. I think we are have a multiple qualification ongoing. We call it Quantify, which is a buffer-free concept. I will show you very soon what does it mean, buffer-free. This is the typical layer by layer piezo structure, and the typical solution has a lot of defects in between, and this is why they need a very thick buffer layer. Typically, it's 2 to 5 micrometer. Our company was enable a new process, and that can ultimately reduce and remove such a thick buffer, while actually improve the structural quality of the material. And this enable several advantage at the device level. This is why SweGaN has attract so many new opportunities along the way. Yeah, we also have other technology, but we will not go through the detail. But this is give everyone a very brief idea about our company, what we have been doing. Thank you.
Okay, thank you, Ted. For now, we'll come back to you shortly in the panel conversation, but let's move on to you, Betty.
Then I will give you a brief introduction of silicon carbide for semiconductor application. Our expertise go all the way back to 1912. That was when our first plant was established in the south of Norway to produce silicon carbide. Then it was established to meet industrial demand in Europe for abrasives and refractory. At the same time, also our trademark Sika was protected, and Sika is a Norwegian abbreviation of silicium carbide. Today, this brand is known in the market as innovative and also for constant high quality. Sustainability is also extremely important for us. So we have been granted the silver of EcoVadis. EcoVadis is highly recognized and valued by our customers globally. And this silver means that we are on the top 15% of the companies in this type of certification. So silicon carbide is used for a number of applications and cutting-edge applications. And like I mentioned, we started with abrasives. We moved over to refractory. And today it's in the advanced ceramics and also lightweight ballistic armor protection and telescope mirrors. Because you need lightweight, you need it to not be worn and to be stable in different temperatures. And now the last years, we also have then developed silicon carbide for the high quality silicon carbide crystal growth for electronic components. So the silicon carbide essentially enabling the green transition. One of the biggest challenges in sustainable electrification is energy loss. Every watt wasted as heat is a step back. Silicon carbide is a wide bandgap semiconductor. That means it can withstand higher voltage, higher temperatures, and also higher frequencies than traditional silicon. Silicon carbide devices dramatically reduce losses, especially in power conversion. This is why you find silicon carbide in electrical vehicles, boosting driving efficiency, and also is essential for enabling the green transition by making power electronics smaller, lighter, and more efficient. So back to silicon carbide for semiconductor application. We group it into two. I will dig a little bit deeper into crystal growth of silicon carbide, but also we have silicon carbide produced to specifically meet demand of producing products for handling tools for the semiconductor processing components. For example, these wafer bows like you see on the mirror here. But for the crystal growth for silicon carbide, you need specifically high purity. And here we are in the beginning of the value chain. And as a first building block, it's extremely important that you have the quality in place and that the quality is consistent. That any impurity introduced at this step can give a high cost later in the value chain. Here we have a very specific position in the Nordic. We have high capacity for this kind of products, and we can scale up to higher volume. And also what we see is the geopolitical landscape in the world at the moment, that we see more and more demand or requests that can we secure the supply to our customers. So being positioned in Norway gives us an advantage. So what for the future? For us, it's extremely important to challenge to be always in the future of the semiconductor research. So we have become a tier 2 member of the Silicon Carbide Innovation Alliances in Penn University at Penn State University. And here as a tier 2 member, we contribute to research for understanding and developing the next generation of silicon carbide material. And we find this collaboration extremely important. In this way, we can secure that they meet the market requirements for power electronics and follow the trends coming in a sustainable way. So I hope I have managed to bring across that collaboration and innovation is in our DNA. We work very closely with our customers, and in many of our end applications, our customers need to secure their competitive advantages. So we are used to work with co-development and to understand what are the technical challenges by our customers, so we can dig deep into that and support and then design also the requested silicon carbide product for them. So if you have any questions, please reach out to us, or you can go to Fiven.com. That Fiven was the previous name of us. So we were acquired by Kymera last year. So on both web pages, you find more information about us. So thank you very much for listening.
Thank you, Betty. Also, for now, we'll come back to you shortly. But before that, let's give the turn to Petri. The floor is yours.
Okay, thank you. So we are working more on the application side, so using, for example, silicon carbide components. So Kempower is making EV chargers, so fast DC EV chargers, which are pretty well known in many countries. So we work quite globally. So blue areas are where we have, let's say, regular sales, technical support offices, and larger dots are manufacturing sites. And this is example of the in European area where our chargers are located. So our home market, we see that it is a Nordic country, so Finland, Sweden, and Norway. That's home area, but let's say Western European or large countries in Western European area are making most of the sales at the moment because there's a lot of cars and people living in the areas. And as you see on the figures, there's quite a lot of energy go through our chargers. And that means that there's a efficiency on charging will play quite significant role on that aspect. And it's not only on the energy, because even more demanding aspect is the peak power. Charging is very cyclic, so peak time there's a demand for the power is very high, and that sets the lots of demands for the grid capacity. So this is showing the basic concept. So we have a centralized power conversion. These cabinets here, the background somewhere, there could be one or more cabinets in one system. Then we have a dispenser units. We call these as satellites. So there's a dispensers on side of each parking slots, or there could be pantographs like this bus case, for example. Then we can distribute dynamically the power from this centralized power cabinet to different dispensers, depending that where there is some vehicle parked at that time. So that's the basically idea. Then we have a Aasheim, which is the cloud-based backend software. So all chargers need to have connected to backend. There's a user identification, invoicing the user, etc. needed. So, but also on the kind of fleet management kind of features. Then when we go closer look on this power cabinet, there's these power modules here shown in the right side of this picture. So inside of this cabinet, there are a number of these power modules. And inside the power module, there's a kind of principle of power conversion stages. So there's three different stages. So input stage, so how to connect to the grid. Then so-called DC-DC, so isolated DC-DC, so primary side of that and secondary side of that, and galvanic isolation between. All those three stages need to have power transistors. And now we are middle of actually two simultaneous transition at the moment. First of all, the traffic or moving is going to electrified. That's the kind of one movement. And secondly, the transistor technology is going to moving. So conventionally, there's used the conventional silicon-based transistors, or IGBTs, on different of these stages. But now there's a moving to ahead to silicon carbides, because it offers a lot of benefits on the, let's say, better efficiency, for example, and higher power density. This is a bit similar picture as shown already, but this shows the, let's say, the movement or size of the movement. So EVs are making the major part of the demand of silicon carbide, this big ball here, or big circle. Then there's a photovoltaics and charging. So these three areas are increasing a lot. If you look on the situation now or a few years back, all these major balls are increasing a lot. So size of the market is increasing because especially these EVs and charging, because the movement to the electrifying the traffic, but same time its component technology is moving ahead to silicon carbide, and let's say likely later on the gallium nitride as well, because those two, let's say, new technologies offers significant benefits also on this EV charging and other applications where especially this galvanic isolation is needed, and thus high operational frequencies are regarded.
Thank you, Petri. So now we are ready to move on to the actual panel conversation. And let's start the conversation with very easy and broad question. Compound semiconductors, why do we need them, and why now?
Well, reduction of loss of energy is key, and also this transition to electrification. And like both Petri and Chen showed, the development of the market is significant. So then to have higher energy efficiency and also reduce the size of components and the weight, then also you can reduce the need of the cooling requirements. So I think the connecting word for all of this is sustainability. So to meet a very growing demand with technical expertise, I think is the importance.
Petri, what do you think?
Yeah, that is exactly as Petri says, that the need for the higher power densities and lower losses are driving on this transition. Also, the costs are driving. The component itself are far more costly at the moment than conventional silicon. But these other components regarded on this kind of power conversion stages, these transformers, for example, these silicon carbide or wide bandgap components will reduce size and cost on these passive components significantly, and that leads to reducing the overall costs. That also is one driver.
Any thoughts on you, Ted?
I think Petty and Patrick give a great summary. I think ultimately efficiency is a key. I think we talk about the loss of this. I think ultimately people would like to save the energy, and that's why I think ultimately what you want to improve is the efficiency, the efficiency of your power electronics. So I think so this is where GaN and silicon carbide can bring to the table to replace I think the conventional silicon.
Correct me if I'm wrong, but compound semiconductors have been studied for decades already. Why are they becoming important only now?
Maybe I can start. I think the compound indeed, and starting from maybe getting arsenide, indium phosphide. But I think a compound now into this, I think the new material, which is a wide band gap, which enable, I think the advantage those, I think other compounds cannot do. So this high breakdown allow you to handle high voltage and high power, and also better thermal properties. And I think this is why, yes, I think when it comes to compound, yes, it's not new, but the wide band gap that is new here compared to I think the second generation gallium arsenide and others. Yeah.
I completely agree that it's a new technology that we have now that really can make us be efficient in this technology. So we reduce the losses we have seen. And also with the new material, we can have high efficiency. So And now the next will probably be to trim the cost to see how to be sustainable and also to be competitive.
Yes, and these silicon carbide transistors, for example, those are, let's say, invented a few decades ago already, but the manufacturing process in let's say mass manufacturing is pretty complicated and expensive, and it takes quite a while time to tune the manufacturing process so efficient that the yield is high enough and the cost is reasonable, and that allows to manufacturing turn to let's say high volume scale, and after that the industry are able to start to use, because then the cost and availability are starting to go in regarded level, and that takes because the complete material itself and manufacturing process is far more complicated than conventional silicon. That takes a long time to develop at this stage.
A little bit of follow-up question to that. What kind of innovations are still needed in order to widen the adoption of compound semiconductors in the industry? Or is it just a matter of bringing the cost down?
I can jump in first. I think to continue to work on the purity on the system and the efficiency, like Petra mentioned, and also the availability to have scale up, that it's available in mass production and also available in the region where you are. But we see also, or we can expect to see more and more pressure of the cost, and also to have then every time you find maybe a larger wafer, you also have to adapt your production equipment to meet then the new scale. So I think we will see innovation also in the coming years, maybe even to standardize, but also to keep the quality, but with a lower cost.
I think today, indeed, there's a lot of advantages that the silicon carbide and gallium nitride could enable, and however, that at quite high expense of cost. So reducing cost is so important, and that will be the driver for the innovation. The other one is to make it so mature. I think ultimately you want to have a high yield of devices. So the innovation must be also in, starting from the material all the way to the device processing to have a high yield. I think that will be very important. I think to really mature such a technology, and then also widen the adoption in the fields.
Yeah, those are very good aspects already told here, but then the cost issue or pressure is already mentioned, and one thing why I personally, let's say, expect to happen is to evolving especially the gallium nitride, as that is, let's say, just approaching the mass production area and turning also on the higher power applications, and there is a lot of development surely to be coming years, and that could be after years, let's say, the lowest cost transistor. But that means that they also topology studies need to do as the, let's say, voltage limitations for the high power or high voltage applications compared to silicon carbide, for example.
Thank you. If we then think a little bit about the sustainability of compound semiconductors, how would you comment perhaps the carbon footprint and the sustainability of this new technology and materials in the different value chain steps? For example, starting from the raw materials.
Yeah, that will be me.
Yeah.
Starting from the raw material then.
Yes.
For us, sustainability and working on reducing emission, and also, of course, the healthy part and caring about neighbors is key. And all our plants are run by hydropower. And I think for us, our ability to scale up is also important, because then we can have more material available with less footprint. So, and also, of course, like mentioned earlier here, that we have a high yield, and when we produce correct the first time, we also have less emission for linked to what you are sending out. So I think for the whole industry to focus on what can we do to reduce emission in our process step, but also what can we do for the next step that we are delivering to enable them to have a good process with low energy and with high yield.
Now, let's move on to the next step in the value chain. Ted, what are your thoughts on the sustainability?
I think for both gallium nitride, silicon carbide, those are the typical process are high temperature. So of course that will, I think, add the footprint. So the carbon footprint. So I think that's also where the innovation needed to reduce the production carbon emission footprint. And also what you need to look at is how much this energy waste those material can save, and then you have an entire picture. So that's where I think we probably have to continue to work on those material. Yeah, indeed they are special, and typical process require high temperature.
Thank you. Moving on to the end user perspective, so to speak. Petri, what are your thoughts on the sustainability?
Yeah, we have done some LCA analysis and comparison, say, between the conventional silicon technology and the silicon carbide technology, and that clear that the component itself, the carbon footprint in silicon carbide is much bigger than conventional silicon. But when you take account on the, let's say, complete power converter stage and lifetime footprint, the majority of the lifetime footprint come from the losses you born on your converter stage. And because the lower losses on silicon carbide, that start to dominate on the, let's say, lifetime scale, and that reduces significantly carbon footprint over the component lifetime. So you should take that account, not only the what is spent on the manufacturing of the component, but what is used on during the lifetime of the complete system or component.
Thank you for the insights. If we then expand from the environmental aspect of sustainability to the availability of materials, how concerned are you under these all geopolitical tensions that is the availability of compound semiconductor materials somehow compromised or possibly compromised? What are your thoughts on that?
Maybe I can start. As today our main, I think our main traction is in RF sector, and we deliver this gallium silicon carbide wafers to different places, and we also procure substrates from different sources. But the one we can share with everyone is today there's no commercially available silicon carbide source in Europe. So indeed, this actually raised a major concern about the supply chain independence, and we are working on that. But today, actually, I'm so glad to hear we actually have a neighbor, and Petty just mentioned that they produce this high quality silicon carbide powder. I think this will help us to build such a supply chain in this region.
Thank you, Chen. That's I call you afterwards.
I actually will call you afterwards.
But I just to continue where you stopped. I see the action we will see now also of the new administration in US and the tariff and all this. We see more and more customers reaching out to us and focus on the secure of supply. So not only in silicon carbide for semiconductors, but also for ballistic applications. It's a growing concern that we have to secure that we have what we need in the region where we are. So we supply globally, but we see more and more, especially in Europe, a request to secure that we have the needed material in Europe, and in this case also in the Nordic. And we can scale up, and we have the material.
How about you, Petri, from the end user perspective, either materials or any other components that comes to your power electronic systems?
Yeah, the manufacturing of silicon carbide wafers, that used to be mostly in US or Asian countries, but nowadays there's some pretty large plants built already in Europe as well. So that the next stage after this material is already, it says, in European based in few suppliers or transistor manufacturers. But as the market size increase, there is still need to have more that capacity than at the moment Europe have. So still there's some dependency on the US and Asian manufacturers on that aspect. And what is a bit strange is that often there's let's say, wafer manufacturing or let's say the transistor process, kind of called as a front-end process, could be in Europe. But then components are sent somewhere in Malaysia or Asia or other side of the world for the packaging. So that's a bit strange to have, let's say, that long supply chains with let's say, very conditions need to be on the packaging of those and transporting back and forth on the planet. So that should be also so that we can have that packaging side closer here in Europe.
If we move on to and discuss the Nordic as a region for power electronics, Nordic is perhaps a region where logic chip manufacturing has moved away. But is the case? What is the case with power electronics? How it is? What is the importance of power electronics at the Nordic level, in your opinion, and what it could be in the future?
Yeah, I can start on the, let's say, application point of view. So here we don't have any volume scale power electronic semiconductor manufacturing in Scandinavia. We have some development units on some component manufacturers here, for example, in Sweden, who make the research and development for the components, but the manufacturing itself is somewhere else. And of course, setting up the manufacturing plants is pretty expensive because this is volume business. You need to have billions of euros, especially on the wafer side or front end side. Maybe some kind of, let's say, back end, so packaging manufacturing on some power modules, for example, could be in Scandinavia. It's don't need to have that much investment than this front end processes. But at the moment, there is no any let's say normal industry scale manufacturing, as far as I know, in Scandinavia.
Maybe I can continue because we know it's challenging to set up such a scale. And to enable such a scale, I think strategic investment, support from the nation level must be in place. I originate from Taiwan, and I think Taiwan is well recognized as really a big powerhouse for semiconductors, and we know they have a long-term strategy from the government to support such an industry. So I think to grow such an industry, we need work together from the academia, from the government, from the industry. We have to work together. I think this is the only way to make such a semiconductor or power electronics to grow in this region. I think this region is known for innovation, but not known for manufacturing. However, I think now everyone knows the rise of AI and also robotic factory. I think this is going to break this convention. I think Nordic can be very competitive because in the future, manufacturing is not a low cost laboring. Manufacturing is a technology. So I think adoption of this AI robotic factory could really empower this region on top of the innovation that we are very strong with. So I still think it's very promising, but it's a race. It's a race to compete with other regions in the world who has been focused on manufacturing, and now they go back to do innovation. So it's a race, but I still think it's very promising. We have to move fast.
Yeah, I agree to what you say, like collaboration and also build the expertise and the innovation. And there is no reason why we shouldn't do this in the Nordic as well. And I know there has been a race for capacity, but to build now with room for constant innovation, I think will be a key for the Nordic.
And that's true, and that we have let's say two major benefits compared to many other countries, which are very, very well educated labor force, and also reasonable low cost energy. So especially this front end processes are pretty energy intensive. So those are two big cost sources on the manufacturing. Rest of those are, let's say, investments, which is costing about the same in no matter where you put that investment.
Should the power electronics be a big growth sector in the Nordics? What do you expect the availability of the labor force? Do we have those here in the region, or do we need to step up in certain aspects? And if so, where? Can you comment
I can
on that?
speak for Sweden because I got the education right here. I think in Sweden, they are long-term strategic initiatives for materials like semiconductors. So we do have a talents right here. But to increase the competitiveness, I think just handle a challenge or just talk about innovation, it's just not enough. I think what we need to do more is speed. It's really the speed. To be innovative in the time frame of 5 years, or to be innovative in the time frame of 1 month, will bring you completely different story. So speed is a key. There are regions, they are so good in not only innovation, but also speed. And that is, for me, is a competitiveness. And when you have to handle innovation in the short period of time, that means stress. We can say we all like the challenges, but the challenges, say if we want to solve one challenge in 5 years' time or solve one challenge in 3 weeks' time, it's a completely different stress. So I think here is also we need to learn how to deal with stress, because to be competitive, you must be able to handle stress in the best possible way, and then also bring the speed in the competition. So I do think we have many well-educated workers, talents right here, but the capacity to handle challenges, this is where we need to further develop together.
How about you, Betty and Petri? Are you finding the right kind of people to support the growth of your company today?
I can jump in first. And I support also what Chen says about speed and capability of handling innovation at a high speed is key. We do find talents, and also sometimes we have to search outside Norway to find talent. We see the collaboration with industry programs together with university is also helpful. And I think in addition to have speed, we also need to have focus to be certain enough that we dare to prioritize correctly, that we don't do everything at the same time and then everything is equally important, that we try to select what is the most important to do and then to focus on that and then bring it to the success.
Yeah, that if I start with the talented people, that is, we can find talented people, but not only in Finland. We have a very international people, especially on the R&D. So in Kempower, we have about 150 people in R&D, and there's roughly 15 different nationalities. So originally many people come from the Finland or Nordics to studying from some other country, and then staying here, find good place to live and work. That is the way to, also one good way to expand, let's say, range of the people that you can find, and very competent people. But I agree that, as Chen said, this speed. There is, in Asian countries, there is a clock frequencies. Some of those countries are very, very high. And that's something that we have to face, that competition. Because nowadays, even nowadays, world is still global, and to be competing globally, and where the investments and factories to be made.
Okay, sounds to me like we are in a very good position to be part in the global competition, and we have a very good chances to succeed. It needs work, but we have a good chances. Okay. This is all the time we have today for our conversation. I would like to thank all the panelists for sharing their expertise with us today. And of course, thank you attendees for tuning in. We invite you to continue the conversation with us in our next in-person meeting, where we bring together the broader community for hands-on collaboration and deeper engagement. Our next meeting will be in Lund, Sweden, at the end of August. So it is right after the summer holiday season. So I really warmly suggest that mark down the dates of August 20th to 21st down on your calendars now. You can find more information on the event at our website, nordicchipcollaboration.com. And while you're there, why not register while you're there? Now, also, please scan the QR code so that you can share your thoughts on the webinar today, but also you can suggest topics for our future webinars, and also things and aspects that you would like us to cover in our Nordic collaboration. Thank you very much for attending, and we're looking forward to seeing you at Lund.